Assalamualaikum. Hi guys. In this video, I'm going to focus about the gas laws. There are 4 general laws that you should understand based on the basic properties of gases. The first one is Boyle's law, the second one Charles' law, AVOGADRO'S law, and combined gas law. Let's go with the Boyle's law first. Boyle's law states that at the constant temperature, so temperature dekat sini constant, the volume of a fixed mass of ideal gas is inversely proportional to its pressure. Apa yang dimaksudkan dekat sini, if you got this kind of experiment, when you pulling up the string or the piston, it will increase the volume but decrease the pressure. But when you push down the piston, it will decrease the volume and increase the pressure. So bila increase the pressure, maknanya movement of gas particles akan lebih faster. Untuk mathematical expression of Boyle's law is shown as at constant temperature and number of mole. Kita tahu volume is inversely proportional to the pressure, and bila kita nak jadikan dia dalam bentuk equation, kita akan letak PV, volume akan darab dengan pressure, equals to the constant. Dan saya akan gunakan small letter K. K is proportionality constant, di mana syarat untuk Boyle's law, you should know that it must be at constant temperature and fixed mass. Maknanya fixed mass ni adalah merujuk kepada same number of moles for specific gases. Dan dalam kes ini, kita boleh relate juga the formula that you got here, P times V equals to 1K. So K is proportionality constant. So from here, you should know volume is inversely proportional to the pressure. So apabila kita ada different pressure and volume, we can relate the Boyle's law with this formula, P1V1 equals to P2V2. Wajib memorize for this formula, and this is for gases at constant temperature. P is the pressure and V is the volume. So you got example 1. So what you should do when you have this kind of example, first thing first, no matter what, you have to extract the information. So I'm going to extract and take out the information given. I got V1 946 milliliter, and I got P1 726 millimeter mercury, and then it asked me to calculate P2, pressure exerted, and dia minta dalam unit millimeter mercury, sekiranya volume V2 reduced to 154 milliliter. And then dia bagi hint dekat sini constant temperature. So maknanya dia relate with Boyle's law. Itu trick dia. So the solution for this one, I'm going to use formula P1V1 equals to P2V2. Dan saya dah ada information dekat sini. All of them I'm going to put into my formula by arranging my subject is P2. Apa yang saya nak cari kat sini. And the pressure P2 is 4459.7 millimeter mercury. So you got the answer. Next one, Boyle's law can be represented graphically as shown as below. Ada several graphs yang awak kena hafal. The first one, graph of pressure versus volume. This is for at constant temperature. Sebab tu dia inversely proportional to the volume. Kita akan terbalikkan dia. Okay, macam ke arah kiri tapi ada curve. Next one, we got graph of pressure versus 1 over volume. So ini adalah untuk linear graph. So you can see that this is linear graph di mana at constant temperature, pressure is directly proportional to 1 over V. So ini 1 over V. Next one, we have the third graph di mana graph of volume versus 1 over P. So y-axis sekarang adalah volume dan x-axis adalah 1 over P. So you got the same case juga, masih lagi sama, linear graph at constant temperature. Dan what you can describe from this graph, at constant temperature, volume is directly proportional to 1 over P. Next one, kita ada the fourth graph, iaitu graph of PV versus P. Di mana awak ada y-axis adalah PV, pressure times volume, dan x-axis adalah pressure. So maknanya kita dapat constant graph. So constant graph ni maknanya dia horizontal line macam this one. So we can understand from this graph at constant temperature, PV is constant. So settle untuk Boyle's law. Next we go for Charles' law. So Charles' law state that for a fixed amount of gas at constant pressure, so sekarang yang constant adalah pressure. Kalau Boyle's tadi dia constant temperature, sekarang Charles dia constant pressure. Itu tricks dia. Next, the volume of gas is directly proportional to the absolute temperature. So apa maksud absolute temperature ni? Awak kena pastikan awak punya temperature unit dia adalah in Kelvin. Must be always in Kelvin. So let's try to understand what Charles' law state first. So Charles' law observe that at constant pressure, the volume of gas expands when heated and contracts when cooled. So contoh analogi dia adalah hot air balloon. Awak boleh nampak dekat sini. Bila kita panaskan balloon, so maknanya dia makin mengembang. So volume dia increase. Tapi bila kita sejukkan dia, volume dia decrease. Maknanya volume itu contracts. Okay, contracts maknanya dia mengecut. So case untuk Charles' law, kita ada mathematical expression juga where it is at constant pressure. And masih ingat, this one number of mole kita ada fixed mass. So fixed mass untuk gas yang kita carilah. So untuk Charles' law, we know that volume is directly proportional to the temperature. So bila saya nak jadikan dia sebagai equation, I will add a constant SK, and then ingat the temperature for Charles' law must be in Kelvin. So kalau lah awak ada temperature in degree Celsius, you have to convert. Okay, jangan lupa convert to Kelvin, di mana tambah sahaja 273.15 Kelvin. And this is for Charles' law. So Charles' law, apabila kita tahu dia relate dengan volume and temperature at constant pressure, maknanya kita boleh relate antara dua parameters ini. V1 over T1 equals to V2 over T2. But don't forget, your temperature must be in Kelvin. So, kena convert apabila awak dapat temperature in degree Celsius. So, let's try example 2. So, example 2, you got carbon monoxide. I'm going to take out the information. So, you got the volume V1. Saya akan set this one 3.20 liter. And then I got the temperature. The temperature right now is 125 degrees Celsius. So, be careful. That's why kita akan convert kepada Kelvin. So, I will have 398.15 Kelvin. So, itu adalah T1. Next one, dia minta saya calculate temperature. So, maknanya saya perlukan T2. And must be in Kelvin. If the gas occupy V2, 1.54 liter. So, volume, kalau guna liter, pastikan 22 liter. Now, the trick here, it said that pressure remains constant. So, maknanya kita kena gunakan formula untuk Charles' law by using this one. V1 over T1 equals to V2 over T2. Dan saya akan rearrange jadikan T2 sebagai saya punya subject. So, I put all those values. I will have my T2 is 191.61 Kelvin. So, inilah jawapan dia. Next one. Charles' law sama juga macam Boyle's law. Dia ada specific graph. So, maknanya awak ada the first one. Apabila we talk about Charles' law, you should know that 0K is called as absolute zero. So, maknanya kalau kita nak represent a graph based on Charles' law, you have graph of volume versus temperature in Kelvin, di mana volume is directly proportional to the temperature and K is the gradient kalau dia minta awak cari. So, this is the normal one, but we got another one more graph for Charles' law, iaitu graph of volume versus temperature in degree Celsius, maknanya you got this one. Apabila awak dapat this one, awak kena extrapolate. Di sini awak kena extrapolate untuk dapatkan nilai for temperature at 0 degree Celsius. So dalam graf ni, awak dah extrapolate untuk dapatkan nilai negatif 273.15. So 273.15 ni bermaksud awak punya nilai 0 Kelvin yang kita panggil sebagai absolute zero. So ini adalah extra yang awak perlu tahu tentang another graph for Charles' law, di mana masih lagi at constant pressure dan volume is directly proportional to the temperature. Kalau volume tu tinggi, maknanya temperature juga tinggi. So we settle for Charles' law. Next one, we are going to learn about combined gas law. So combined gas law only for combination of Boyle's law and Charles' law. So for Boyle's law, we know that we have temperature is constant. And for Charles' law, we have pressure is constant. Tetapi, bila kita combine, subjek dia masih lagi volume. Tapi, T dekat sini, for Charles' law akan darab dengan 1/P. That's why I have T/P, temperature over pressure. Ataupun kalau saya rearrange sebagai equation, saya akan darab this one and then saya akan bahagi dengan temperature. Dan I got my proportionality constant K. So, ini adalah formula untuk combined gas law. So, apa yang dimaksudkan dengan combined gas law dekat sini? Sekiranya temperature and pressure change at the same time, pressure, volume and temperature, awak akan dapat another formula iaitu this one. And then, sekarang kita nak apply dalam problem solving. So, bila kita nak solve the problem, apabila kita involve two conditions right now iaitu dua parameters. Yang pertama adalah pressure dan yang kedua adalah temperature. Apabila kita combine Boyle's law and Charles' law, awak akan tulis sebagai P1V1 over T1 equals to P2V2 over T2. Dan dalam kes ini, mass is constant ataupun number of mole is constant. Dan jangan lupa, temperature masih lagi in Kelvin, wajib kena convert. Let's apply this equation dalam satu example. So let's apply the formula that we've learned so far in this example 3. First, I'm going to take out the information. So this is what you have. Dan kita perlu cari P2. So, you should assume that number of moles remains unchanged. So the solution for this one, we are going to use this formula. I'm going to rearrange this formula to get P2 as my subject and then you put all those value. Dalam kes ini, awak boleh kalau nak convert ataupun tidak convert temperature. Tapi saya nak lebih senang dan lebih sesuai untuk kefahaman saya terus convert kepada Kelvin. That's why I put my temperature value in Kelvin. And untuk yang lain, kekal sahaja. Then you got the final pressure 1311.86 torr. Next, we go for Avogadro's law. So Avogadro's law states that at constant pressure and temperature, so dalam kes ini, yang constant adalah dua parameters, pressure and temperature. The volume of a gas is directly proportional to the number of moles of the gas present. So contohnya, saya ada pressure yang constant dan temperature yang constant. Apabila saya apply the pressure at 1 atm, so maknanya sama, I can see that the number of mole change based on the volume. Apabila kita add the gas, volume dia increase, moles dia pun increase. Kalau kita reduce the gas ataupun remove the gas, volume dia decrease, mole dia pun decrease. So, untuk this law, masih ada juga formula yang spesifik at constant pressure and temperature. We know that the volume is directly proportional to the number of moles of gas. So, I will get V over N equals to proportionality constant. Then, when we want to apply at different volume and amount of gas, we have V1 over N1 equals to V2 over N2. So let's try this example. Keluarkan information yang awak ada. Untuk kes ini, kalau lihat, awak ada perkataan when another 3 moles of chlorine gas. So maknanya N initial adalah 2 moles. Tapi bila kita tambah another 3 moles, maknanya awak punya N2 adalah hasil tambah 3 dan 2. So sebenarnya awak akan dapat N2 5 mole. Then you want to calculate V2 right now. So by using this formula, I put the value by rearrange my subject as V2, I got 122.5 liter. Into Avogadro's law, graph for Avogadro's law will be graph of volume versus number of mole. And we know that at constant pressure and temperature, volume is directly proportional to the number of moles of gas. So volume as our y-axis, moles as our x-axis. Apabila we talk about volume here, awak kena faham, kita belajar dalam chapter 1 about molar volume. So maknanya, awak kena relate which molar volume we are talking about. Because molar volume is the volume occupied by 1 mole of any gases. Sebab tu dipanggil molar volume. Molar tu merujuk kepada 1 mole. Dan dia depends on its temperature and pressure. So, kita ada 2 jenis molar volume at standard temperature and pressure, STP, and at room temperature and pressure, RTP. Saya harap you still remember about this one. For example, if I have at constant pressure and temperature, awak akan nampak relationship between these 3 gases di mana number of moles dia akan sama sekiranya volume dia sama. So, itu adalah relationship yang kita sudah belajar dalam konsep molar volume. So, why not we apply the concept that we've learned so far into this example, example 5. You have to find out the volume of hydrogen gas obtained from the reaction of 6.50 gram of zinc with excess sulfuric acid at STP when pressure and temperature are constant. So, trick dia dekat sini, hint dia bagi pressure dengan temperature constant. So, maknanya kita akan gunakan formula mengikut konsep Avogadro's law. So, first thing first, I'm going to take out the information given. So, I have mass of zinc, which is 6.50 gram. And after that, I have zinc reacts with sulfuric acid. The formula for sulfuric acid is H2SO4. And then we have molar volume. So this is molar volume at STP, standard temperature and pressure. And you have to find out the volume of H2 gas. This is what you need to find out. So my solution to start with, I need to put the chemical equation first. So for this part, we have to put the balanced chemical equation when zinc reacts with H2SO4 to produce ZnSO4 with hydrogen gas. So the one that we need to find out is this volume. How much? And we have mass for this one, which is 6.50 gram for zinc. So bila kita ada this information, I hope you still remember how to apply based on chapter 1, the stoichiometry. So the stoichiometry, we are going to relate between zinc and H2. But let's find out the mole for zinc first, because when we want to do the stoichiometry, we need the mole to compare between 2 items. So find out the mole of zinc. I have mass over molar mass for zinc. So the mole I have here is 0.10 mole. And after that, I'm going to continue my solution by using the stoichiometry. I'm comparing the mole between zinc and H2. So from the balance equation, we have the coefficient 1 in front of both of them. So the mole for zinc will be equal to the mole of H2. So you got the mole of H2 right now. So now you can use this value to find out the volume of H2 gas at STP. So the molar volume for gas at STP is 22.4 dm cube per mole, and put the number of mole times both of them, you will have the final value. Volume of H2 gas is 2.24 dm cube, or you can put as liter. So basically formula ini adalah apa yang kita dah belajar waktu chapter 1, cuma kita just apply because it is under the concept Avogadro's law. So far you've learned a lot of gas laws here. You've started with Boyle's law, and then next one you continue with Charles' law, and then combine gas law di mana you combine Charles and Boyle's law. Seterusnya awak belajar Avogadro's law, and you relate the molar volume in Avogadro's law. So maknanya a lot of things to understand, but what you should know, you need to understand the concept dan ingat formula sebab ada banyak calculation untuk this subtopic. So itu sahaja from me for this video. I will see you in the next one. Bye!